Hi, my name's Amanda and I'm a pharmacist. Today I'll be talking about a type of pharmacy calculation called IV flow rates. And if you find this video useful, please press the like button and subscribe to my channel and share it with others who may find it helpful too. Thanks, I really appreciate it. So we'll begin with what are flow rates. A flow rate is the volume per time that a medication is delivered by intravenous or IV route to a patient. It's also known as a drip rate or infusion rate. So you can see flow rate equals volume per time. So volume, this is for liquid measurements. It can be liters, milliliters, or drops. Time, this is a time measurement such as hours or minutes. And just to show you some examples of some common flow rate units, there could be milliliters per hour or drops per minute. And there you see it's volume per time. So now we'll talk a little bit about IV administration sets. IV administration sets or IV sets deliver IV solution to the patient by connecting to the IV bag. IV sets work by either a gravitational drip chamber, you can see this in photo 1, or an electronic infusion pump. And this is an example in photo 2. Electronic pumps, they can be set at various flow rates. But with a gravitational drip chamber IV set, they have different drop factors that are used in flow rate calculations. Now we'll talk a little more about that. A drop factor, or also known as a drip factor, is the number of drops it takes to have a volume of 1 milliliter. So the drop factor units are drops per ml, or if you remember in our abbreviations, drops is abbreviated gtts, so gtts per ml. There are different IV sets that have different drop factors. There's what's known as macro sets, and macro means large, so you can think of these as having a large amount with each drop. For example, 10 drops per milliliter. It would only take 10 drops to make 1 milliliter. And then there are micro sets, and micro means small. So you can think of these as having a small amount with each drop. So an example would be 60 drops per milliliter. The drops are small, so it's going to take more drops for 1 milliliter. In this case, 60 drops. Now we'll talk about solving flow rate calculations. Flow rate calculations can be solved by using conversions and ratio and proportion calculations. And it's important that you know the common conversions. Conversions that are often seen in flow rate calculations include volume, time, and dosage ones. And here I have a table that shows some of the common conversions for flow rate calculations. Liters to milliliters, so 1 liter equals 1,000 milliliters. Hours and minutes, 1 hour equals 60 minutes. Grams with milligrams, 1 gram equals 1,000 milligrams. And milligrams with micrograms, 1 milligram equals 1,000 micrograms. Now we'll look at the steps for solving flow rate calculations. First, you want to identify the unit or units the problem is asking for. This could be just a single unit such as milliliters or hours, or it could be multiple units such as milliliters per hour. Next, you want to use the other information in the problem to get the units needed. And there are 2 methods for this. And if you've seen any of my other pharmacy calculations videos, you'll recognize these methods are from my conversions video. So it's the same exact methods. Method number 1, you can set up fractions that cancel like units, leaving the desired units only, then multiply the fractions. So for example, if we're trying to convert 5 hours into minutes here, we know there are 60 minutes per 1 hour times 5 hours over 1. We have an hour on the top, an hour on the bottom, so those units cancel. We're left with minutes, and then we just multiply the fractions. So 60 times 5 is 300, then divided by 1 times 1, which is 1. That gives us 300 minutes. Or we can use method 2. Set up equivalent fractions, cross multiply, then divide to solve for x. So for this example, we'll use the same example as the 5 hours, converting it to minutes. So there are 60 minutes per 1 hour, and we'll set that equal to x minutes per 5 hours. And notice with these you have to have the same units on the top and the same units on the bottom. So we have minutes on the top, hours on the bottom. So 60 times 5, that's our cross multiplication, is 300. Then we'll divide by 1. That gives us 300, and that solves for x. So x here is 300 minutes. And you can use whichever method makes the most sense for you, or whichever method makes the most sense for the problem that you're solving. Okay, now we'll look at some examples of flow rate calculations. This is example 1, and I'm going to work through both methods with all of our examples so you can see multiple ways to do these calculations. So this is with method number 1. So our order is for 1200 milliliters of NS, and NS stands for normal saline. This is 0.9% sodium chloride solution. So 1200 milliliters of normal saline to be infused over 8 hours. How many milliliters will be infused every hour? So first we're going to identify our units the problem's asking for. And here it's milliliters. So with method 1, we'll set up our fractions that cancel like units, then multiply the fractions. So we can know there's 1200 milliliters per 8 hours. Milliliters is the unit that we're wanting. And then times 1 hour. We want to know how many milliliters for every hour. So it'll be 1 hour over 1. We have an hour on the top, an hour on the bottom, so the hours cancel. We're left with milliliters. And if we do the math, 1200 times 1 is 1200 divided by 8 times 1, which is 8. That gives us 150 milliliters. And if you're using method 1, if there's only one unit that you're trying to solve for, make sure it's on top. That will make sure that you get the correct answer. And just remember, for units to cancel, you must have it one unit on the top and one on the bottom. That's how they'll cancel. And to make a fraction that has only one unit, you just put a 1 with it. And that can be either on the top or the bottom. In this case, it was on the bottom. Okay, now we'll look at the same example with method number 2. So example number 1 with method number 2. So our order was for 1200 milliliters of normal saline to be infused over 8 hours. How many milliliters will be infused every hour? So here we're looking for milliliters. And with method 2, we're going to set up equivalent fractions, cross multiply, then divide to solve for x. So we know there's 1200 milliliters per 8 hours, and we'll set that equal to x milliliters per 1 hour. And for x here, it's the variable representing the answer we're looking for. And our unit of the top fractions, which those are numerators, they have to match, and they do. They're both milliliters. And the unit of the bottom fractions, which are denominators, those must match, and they do. They're both hours. So now we'll just cross multiply, then divide to solve for x. So 1200 times 1 equals 1200, and then we'll divide by 8 to solve for x. So 1200 divided by 8 equals 150 milliliters. Okay, now we'll look at example number 2 with method number 1. So it's a very similar problem here. We have 1200 milliliters of normal saline to be infused over 8 hours. How many milliliters will be infused every 10 minutes? So we're looking again for milliliters, but instead of for every hour, we're going to find for every 10 minutes. So with method 1, we'll set up our fractions that cancel like units, then multiply the fractions to get the answer. So we have 1200 milliliters per 8 hours times 1 hour per 60 minutes, and we have an hour on the top, an hour on the bottom, so those cancel. And then we have going to multiply that by 10 minutes over 1. So now our minutes will cancel. We have a minute on the top and minutes on the bottom. Those cancel, and we are left with what we want, milliliters. So now we'll just do the math. 1200 times 1 times 10 equals 12,000. And then divided by 8 times 60, which is 480. So 12,000 divided by 480 equals 25 milliliters. Okay, now we'll look at the same example with method number 2. So 1200 milliliters of normal saline to be infused over 8 hours. How many milliliters will be infused every 10 minutes? So we're looking for milliliters here. And with method 2, we'll set up equivalent fractions, cross multiply, then divide to solve for x. So we know 1200 milliliters, and we're going to set that over 480 minutes. And in the rectangular box here, I have how I converted the 8 hours into 480 minutes. So 1 hour equals 60 minutes. And then there are 8 hours here, so 8 hours times 60, that equals 480 minutes. So we have 1200 milliliters over 480 minutes, and we'll set that equal to x milliliters over 10 minutes. So 1200 times 10, so our cross multiplying, equals 12,000, and then we'll divide by 480 to get x, and that equals 25 milliliters. Okay, now we'll look at example number 3 with method number 1. Our order is for 500 milliliters of D5W, and D5W, that means dextrose 5% in water solution. So 500 milliliters of D5W to be infused over 6 hours. What is the flow rate in drops per minute? And drip rate equals 60 drops per milliliter. So if we identify our units the problem's asking for, it's drops per minute. So with method 1, we know our drip rate is 60 drops per milliliter. We'll multiply that by 500 milliliters per 6 hours. So we have a milliliter on the top and a milliliter on the bottom, and those cancel. And then we know there's 1 hour per 60 minutes, so we'll multiply that by 1 hour over 60 minutes. So we have an hour on the top, an hour on the bottom, and those cancel. And we're now left with our drops on the top and minutes on the bottom. So that will give us the correct answer once we do the math. So 60 times 500 times 1, that equals 30,000, divided by 6 times 60, that's 360, and that gives us 83.3, and we'll round that to 83, so it's 83 drops per minute. Okay, now we'll look at example number 3 with method number 2. Our order is 500 milliliters of D5W to be infused over 6 hours. What is the flow rate in drops per minute? And our drip rate is 60 drops per milliliter. So if we identify our units, we're looking for drops per minute. And with method 2, we'll set up equivalent fractions, cross multiply, then divide to solve for x. So we have 60 drops per 1 milliliter, that's our drip rate, and we'll set that equal to x drops per 500 milliliters. So this will give us the first unit, our drops with this one. So 60 times 500 equals 30,000, and then divided by 1, that gives us 30,000, so it's 30,000 drops. Now we need to look at the time part of this. We know 1 hour equals 60 minutes, and this is for 6 hours. So 6 hours times 60 would be 360 minutes. So we'll take 30,000 drops divided by 360 minutes, and that gives us 83 drops per minute. Okay, now we'll look at example number 4 using method 1. So our order is for 1 liter of D5W to be infused over 6 hours. If using a 10 drop per milliliter IV set, how many drops per minute will be delivered to the patient? So we'll identify our units the problem's asking for, and this is drops per minute. And with method 1, we'll set up our fractions that cancel like units, then multiply the fractions. So we know 1 liter equals 1,000 milliliters. So we'll start with that. 1,000 milliliters per 1 times 10 drops per 1 milliliter times 1 hour per 60 minutes times 1 over 6 hours. And this cancels milliliters. Cancel. We have a milliliter on the top, milliliter on the bottom. We have an hour on the top, an hour on the bottom. And that leaves us with our units we want, drops per minute, drops on the top, minutes on the bottom. So we'll do the math. 1,000 times 10 times 1 times 1 would be 10,000. And then we'll divide that by 1 times 60 times 6, which would be 360. And that gives us 27.8 drops per minute. And we'll round that to the nearest number, which would be 28 drops per minute. Okay, now we'll look at the same example 4, with method number 2. So our order is for 1 liter of D5W to be infused over 6 hours. If using a 10 drop per milliliter IV set, how many drops per minute will be delivered to the patient? So we're looking for drops per minute, and with method 2, we'll set up our equivalent fractions, cross multiply, then divide to solve for x. So 10 drops per 1 milliliter equals x drops per 1,000 milliliters, because we know that 1 liter equals 1,000 milliliters. We can go ahead and do that. So if we cross multiply and divide, we have 10 times 1,000 equals 10,000 divided by 1. That gives us 10,000 drops. So that's the top part of our unit. Now we have to find the other part, the minutes. So 1 hour equals 60 minutes, and there are 6 hours here, so 6 hours times 60, that's 360 minutes. So now we take 10,000 drops divided by 360 minutes, and that equals 27.8 drops per minute, and we'll round that to 28 drops per minute. Now we'll look at example number 5, and we'll start with method 1. So our order is for vancomycin, and I have a note here about IV vancomycin. It must be administered slowly at a rate no faster than 1 gram per hour or 10 milligrams per minute to prevent an adverse reaction called vancomycin flushing syndrome, or VFS. And this causes just flushing and redness in the face and upper body. So remember that IV vancomycin has to be administered slowly. So now with our problem, so our order is for vancomycin, 1.5 grams per 500 milliliters at 10 milligram per minute rate. How long would it take to deliver the medication at the correct rate? So first we'll identify the units the problem's asking for, and this doesn't specify units, but it's asking for time. So this could be minutes or hours. So with method 1, we're going to set up fractions that cancel like units, then multiply the fractions. So our rate is 10 milligrams per minute, but we're looking for time, so we're going to put minutes on the top. So it will be 1 minute per 10 milligrams times 1,000 milligram per 1 gram. Now we have a milligram on the top and a milligram on the bottom, those cancel. And then times 1.5 grams over 1. So now we have a gram on the top and a gram on the bottom, and those cancel. So we're left with minutes. And if we do the math, 1 times 1,000 times 1.5 is 1,500, divided by 10 times 1, that's 10. That gives us 150 minutes. And we know there are 60 minutes in an hour, so we can divide 150 by 60, and that will give us 2.5 hours. Now we'll look at example number 5 with method number 2. So our order is for vancomycin, 1.5 grams per 500 milliliters at a rate of 10 milligrams per minute. How long would it take to deliver the medication at the correct rate? So first we identify our units the problem's asking for, and it says how long, so we know that's time. So this will be in minutes or hours. And with method number 2, we'll set up equivalent fractions, cross multiply, and then divide to solve for x. So first we'll set up, we know there's 1,000 milligrams per 1 gram. We'll set that equal to x milligrams per 1.5 grams. And if we do the math, the cross multiplication, 1,000 times 1.5 is 1,500 divided by 1. That gives us 1,500 milligrams. So now we have the units that we need to determine the minutes based on having the rate. So 1,500 milligrams over x minutes equals 10 milligrams per 1 minute. So cross multiply, 1,500 times 1 is 1,500 divided by 10. That gives us 150. So x is 150 minutes. We can divide that by 60. That will give us how many hours? So that's 2.5 hours. And something to notice about this vancomycin calculation, sometimes in these flow rate calculations you're given additional information that you may not need. So this one, it had 500 milliliters. We did not need that to solve this calculation. So that's something also to be aware of in the flow rate calculations. Now we'll look at a summary and some key points to remember about flow rates. So a flow rate is the volume per time that a medication is delivered by intravenous route to a patient. It's also known as a drip rate or infusion rate. And IV sets have different drop factors, which the units are drops per milliliter, that can be used in flow rate calculations. And flow rate calculations can be solved with conversions and ratio and proportion calculations. So you can use method 1, where we set up fractions that cancel like units and then multiply to get the answer. Or you can use method 2, where you set up equivalent fractions, then cross multiply and then divide to solve for x. Thanks for watching. Please like and share this video with others who may find it helpful, and please subscribe to see more of my drug information videos. Thank you.